Assalamualaikum and hi. Our group will be present for our QMT 342 assignment regarding queuing theory. It is conducted at Family Mart ZAMANI. So, this is the introduction. I will introduce our group members. My name is Amir Rashid bin Muhammad Nasir, and this is the other three group members, Fatina Shah binti Ramli. Next one is An-Nisa binti Muhammad Zamri, and the last one is Aina Shakina binti Rahim. So the next one is, for this assignment, we choose to collect data at Family Mart. It is a Japanese franchise business of convenience stores. Furthermore, it is the second large convenience store in Japan. On November 11, 2016, Family Mart launched its first stores in Malaysia at the Wisma Lim Foo Yong Shopping Centre in the Bukit Bintang neighbourhood of Kuala Lumpur. It was the first convenience shop in the area to provide soft-serve ice cream and fresh food and quickly gained a lot of customers. The store that we chose is located at Taman Utama, Segamat. On the day we conducted our data collection, there are two counters for service. However, only one counter is open due to short staff. Therefore, in this case, it is only a single channel.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Shakina binti Rahim. My matrix number is 2020893112. So now we are moving to the characteristic on the queuing system. First, 2.1 observational table. Since we have conduct an observation of the customers that come to the Family Mart within 1 hour, therefore we found that in 1 hour, 33 customers has come to the Family Mart. This is the data that we have collect at that time. Next, we're moving on to 2.2 to make some calculation. We need to do some calculation to find the average number of arrivals per period, which is lambda, and the average number of customers served per period, which is mu. First, we calculate the average number of arrivals per period. Our total customer is 33 customers. Therefore, our average number of arrivals also 33 customers per hour. Next, we calculate the service time by finding the duration between service start and service end. The average service time is 50 minutes divided by 33 customers per hour, then we got 1.5 minutes. Meanwhile, to get the mu, 60 minutes divided by 1.5 minutes, then we got 40 customers per hour. Next, we are moving on to 2.3 arrival characteristics. For the first one is the size of calling population, which is infinite or unlimited. It means that the arrival rate is not affected by the number of the customers in the queuing systems. The next one is the pattern arrivals at the system. The assumption for arrival at the Family Mart follows the Poisson distribution, where the lambda here is 33 customers per hour. The last one is the behavior of the arrival, which is the patient customers, that the customers are waiting in the queue patiently until they are served. The next one is 2.4 waiting line characteristics. For the first one is the length of the line, which is infinite or unlimited. It means that there is no restriction on the number of people who are waiting in the line or in the queue. And the next one is the queue discipline. The Family Mart applied the concept of first in, first out, or FIFO, or sometimes it called first come, first serve. Next, we're moving on to 2.5 service facility characteristics. The first one is the configuration of the service system. For the number of the channel is a single channel system, which means that there is only one counter is open or there is only one server. For the number of phases or situations, it is a single first system, which means that the customers are served only at one station. The second one is the pattern of the system. The assumption for the service time follows the exponential distribution, where the mu equal to 40 customers per hour. Last one, 2.6 basic queuing system configuration. For the Family Mart, the basic queuing system configuration is a single channel, single phase. To elaborate, the customers will arrive and make purchase, and then they wait in the queue to make the payment. Plus, they will leave the Family Mart. That's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
When we are collecting the data, Family Mart use a single channel, single phase system. So there is only one counter that is being used. So the flow is once the customer arrive, they will queue in only one line, and then they will be served also only at one counter. After the customer is done being served, they will leave the store. Queuing model single channel. Let's move on to the calculation. According to our observation, there are 6 computations that we can use to solve this queuing system. So, before we start with the calculation, here are some of the information that we obtain while we are collecting the data at the Family Mart store. The first information is arrival rate, which is lambda equals to 33 customers per hour. The second one is service rate, which is mu equals to 40 customers per hour. And the last information is the number of server, which is S equals to 1. So, for the first computation, we can find the probability that the service facility is being used by using the formula rho equals to lambda over mu. So, by substitute the value of lambda and mu, which is lambda equals to 33 and mu equals to 40, we will get the answer, which is 0.825, which is the probability that the service facility is being used. Next, for the second computation, we can find the probability that no one is in the system. So, we can use the formula of P naught, which is equals to 1 minus lambda over mu. Same thing, we just need to substitute the value of lambda and mu, which is 33 and 40. So we will get the answer 0.175. Other than that, we can also find the percentage idle time by using the answer. So we just need to multiply it with 100. So we will get the percentage is 17.5%. Next, we can find the average number of customer in the queue by using the formula of LQ equals to lambda square over mu times mu minus lambda. So, when we substitute the value of lambda and mu, we will get the answer is 3.8893, approximately equals to 4 customers. Other than that, we can also find the average number of customers in the system by using the formula of L equals to lambda over mu minus lambda. When we substitute the value of lambda and mu, we will get the answer 4.7143, which is approximately equals to 5 customers. Moving on to the next one, we can find the average time a customer spends in the system by using the formula of W equals to 1 over mu minus lambda. So, when we substitute the value of mu and lambda, we will get the answer 0.1429 hour. Last but not least, we can find the average time a customer spends in the queue by using the formula of WQ equals to lambda over mu times mu minus lambda, which is equals to 0.1179 hour.
In conclusion, give a comment on the number of servers provided and the customer waiting time. First, is the number of servers provided adequate? Yes, the number of servers provided adequate because the customer are being served at a faster rather than they arrive. Secondly, are the customer are happy with the waiting line? Yes, the customer are happy with the waiting line because they are being served on time and no need to wait too long to be served. Next, describe what you have learned from doing the project. When the average service rate is
which is mu is greater than average arrival rate, which is lambda, the server provided are enough to serve customer. But when the average service rate is less than average arrival rate, the server cannot handle too many customer. That's all from us. Thank you.